Hi, this is Rethik, your biology subject matter expert from MemoNeet, and once again, welcome to the biology series. So, in this video, we are going to, discuss on enzymes. So, what are enzymes? What are the factors which are going to affect the enzymes, and classification of enzymes and cofactors? So, my dears, what do you mean by enzymes? Almost all enzymes are proteins. That is what we commonly define. There are some nucleic acids that normally behave like an enzymes. So those nucleic acids which actually behave like an enzymes, right? We normally call them as ribozymes. So one can despite an enzyme by a line diagram. So that means we can actually, describe them through by using a line diagram. So enzymes, like any other proteins, even enzymes will be having a primary structure. That is, it will be consisting of amino acid sequence of the protein. So an enzyme, like any proteins, again they will be having not only the primary structure, but also they will also be having what? Secondary and tertiary structure. So when we look at the tertiary structure, students, you will notice that the backbone of the protein chain folds upon itself. Like the chain will be crisscross itself. So you know what is crisscross, right? So if you know the chemistry and how the structure of protein and all, so you will be able to understand it in a better way. So the structure where many there are some active sites in the enzymes also. So what is this active site then? So active site of an enzyme, it is actually a pocket into which the substrate comes and fit. Say like if this is an enzyme, okay, and this part is an active site, so there a substrate will come and fit into this active site. So thus enzyme through their active site catalyze a reaction at higher rate. Enzymes catalysis differs from inorganic catalysis in many ways. But one major difference which need to be mentioned is in inorganic catalysis work. So whatever that is we are subjecting, that is inorganic catalysis, right? So they work more effectively or efficiently at higher temperature and higher pressure when enzymes get damaged at higher temperature, but still it works really very well. However, enzymes, they are isolated from the organisms who normally live under extreme high temperature, say like at a, molten state like volcano and all, hot vents and sulfur springs and all. So there you cannot imagine the existence of living organisms. So the organisms which are able to survive even in that condition, right, from them these enzymes are extracted. Okay. Say like temperature which has to be up to 80 to 90 degrees Celsius. So thermal stability is thus an important quality of such enzyme isolated from thermophilic organisms. Majorly enzymes are being isolated from what? They are being isolated from this thermophilic organisms. This is one point. And most of the enzymes which are extracted, right, they will be, showing the stability at a very highermost temperature. So chemical reaction. So chemical components undergo two types of changes. One is a physical change, simply refers to the change in the shape without breaking the bond. So this is a physical process. We have another physical process uh, where a change in matter, change in the state of matter is considered. Like when ice melts into water, then water becomes vaporized. So there is a kind of physical process here. So another thing is when a bond are broken, a new bond is formed during this transformation. So this will be called as what? Chemical reaction. For example, this is how you are going to see a new bond. So hydrolysis of starch into glucose is an organic chemical reaction. So rate of physical or chemical process refers to the amount of the product formed per unit time. So this is rate of chemical process refer to the amount of product, amount of product formed per unit time. Okay. So that means the rate can also be called velocity in its direction if it is specified. So rate could be both physical and chemical process, and they have been influenced by what? Temperature, among other factors. So a general rule is the rate doubles or decrease half for every 10 degrees Celsius change in either direction. Say like if 10 degrees Celsius of temperature has been changing, right? Either the rate could be doubled or it could be decreased. That means all overly, the catalysis or catalyzed reaction process at rate varies higher than that of the uncatalyzed one. That means when an enzyme is there, okay, so when enzyme catalyzed reactions are observed, the rate would be very higher than that of the same where uncatalyzed reaction, where enzymes are not used. That is what they are trying to say. So how, see, in absence of enzymes, this reaction is very slow. That means whatever the reaction that you are seeing, like carbon dioxide and water, so carbonic hydrides. So what happens as a result? Carbonic acid is providing, right? So this reaction in absence of enzyme, the reaction could be very slow, with about 200 molecules of this being formed in an hour. So that is here you can see if there is no enzymes, what happens? The carbonic acids that we are seeing, right? It could be lesser being formed in an hover. However, by using an certain enzymes, okay, present within the cytoplasm. So what enzymes has been used? That is carbonic anhydrase enzyme. So can you see here? This is an enzyme here. That is carbonic anhydrase is an enzyme which is used. As a result, what happened? There is a drastic change. Okay, a speed will be more like carbonic acid production will be more like more than like 6 lakhs molecules being formed at every second. So that is how it differs. Then how do these enzymes bring about such high rate of chemical conversation? Like how and why? So that is what we need to see. See, as here, what happens? The chemical which is converted into product is actually called as what? Substrate, right? Hence, enzyme, that is protein with a three-dimensional structure includes, that means in an enzyme, it includes what? An active site. So this is an active site now. Okay. So what happens? So that is going to convert into substrate and convert a substrate into product. That is, if you can see in this graph, so this is the substrate. Once they come and bind to the enzyme active site, right? As a result, both get combined and that will be produced into what? The product. So it is now understood that the substrate, yes, right, has to bind to the enzymes at its active site. So within a given cleft or pocket, that is within that place only it has to bind. Not every substrate can bind to every enzymes. Only specific substrate can go and bind to the specific enzymes. So the substrate has diffuse towards this active site. Thus, what happens? There will be a formation when an enzyme and substrate are binded. So we normally call them as ES complex, that is substrate enzymes complex. Okay. So formation of ES complex, enzyme substrate complex can be seen. So where E stands for enzymes and S stands for what? Substrate. Right. So during the stage, what happens? As I told an enzyme, we have an active site. So there the substrate comes and forms a bond, right? So this is called as transition state structure is formed. So that stage is actually called as transition stage. Very soon after once the bond is made, that is the bond is completed. So the product is been released from the active site. Okay. In other words, what happens when the structure of the substrates gets transformed into the structure of the protein? That means once they go and form a bind with the enzymes, right? As a result, the substrate gets transferred into the products. So this pathway of transformation from substrate to product, that must go through, and that is actually called as transition state structure. Getting? So this is what called as transition state structure. So there is a process of reaction, how it normally happens. So there could be many more alternative, altered structural states, but between the stable substrate and the product. That means from the substrate to becoming a product, there are many alternative states, okay? But the stability is something related to energy status of the molecules or to the structure. Say like if this is an axis, right? So this is what? Y-axis, and this is x-axis. So this y-axis normally represents what? A potential energy, okay? And x-axis represents the progress of reaction here. Okay, the progress of reaction or the progress of the substrate getting transformed, right? So transformation state can be seen. So you will notice two things here. One is the energy level difference between the S and P, that is the energy level difference between the substrate and the product. So if product is at the lower level, that means if it is at the lower level, what happens? The substrate, the reaction is an exothermic reaction. Okay. So when the product is at lower level, then the substrate reaction will be exothermic reaction. So one need not supply energy. That means in this reaction, what happens? You don't require any supply of energy, that is heat, in order to form a product. But in exotherm or spontaneous reaction or an endothermic or energy required reaction. So what happens? If the product is more, then energy is required. Okay, energy is required in order to make that transition happen. So the substrate has to go through much higher energy state. That's what I'm trying to say here. So the difference in average energy constant of S, okay, that is the substance from that of the transition state, that is from substances to the product, right? So the energy required is more here. So that is activation energy. We normally call it as what? Activation energy. So activation energy with enzyme, you just require obviously you require energy, but it will be happen very soon. But activation energy without enzymes, it take a longer period of time. So enzymes eventually bring down this energy barrier, making the transition of substrate to what? Product more easily. Okay. So in this way, enzymes plays a very important role in forming from the substrate to the product. So nature of enzyme action. So each enzyme has a substrate. That is what we got to know. So substrate binding site. That means each enzyme, if this is an enzyme, right? So we just got to know that there will be a what? Substrate binding site, so that a higher reactive enzyme substrate complex is produced. So if an enzyme and substrate comes and bind to it, we normally call them as enzyme substrate complex is formed. So this complex is short-lived and dissociates into product. That means it is not the permanent one. Once it is done, once the bonding has happened, immediately that substrate turns into a product, and unchanged enzymes with an intermediate formation of enzymes product complex. Clear? So that is enzymes plus substrate will give what? Enzyme substrate complex, and that substrate will be converted into protein. So enzyme product complex. So sorry, enzyme substrate will be converted into enzyme product complex. And later on, what happens? They get differentiated and only product is released out. Clear? So this is how normally it happens. Next, the catalytic cycle of an enzyme's action can be described in the following state. How this happens? So first thing, as I have explained you before, so what happens? So there is this enzymes, right? There is an enzyme here. So there is a substrate binding site, which is an active site now of an enzyme. So our substrate comes and fit into this active site. Okay, say like a substrate. So this is substrate comes and fit into this active site. So binding will happen. That is enzymes and substrates will bind, right? So this induces the enzymes to alter its shape. So fitting more tightly around the substrate. So later on, once they are been binded, right? The active site of the enzyme, now it is close proximally. At that moment, it is closed. Now other substrate cannot come and bind to that position. And later on, what happens? Now the substrate breaks the chemical bond of the substrate and new enzyme product complex is formed. That is, as a result, an enzyme and product complex, EP, is formed. Okay. So now the enzymes releases the product. So from this, what happens? The enzyme is going to release the product of the reaction and free enzyme. Now this enzyme is again ready to bind another molecule of the substrate and run through the catalysis cycle once again. You're getting? So once if there is an enzyme, now what happens? The substrate comes and bind to it, make a bond, and that substrate breaks its chemical bond to form a product. So now it is enzyme product complex is formed. From there, what happens? The enzymes is going to release the product and we got a product now. And now this new enzymes, again, this enzyme is ready to bind another molecule, okay, another of the substrate, okay, and the cycle keeps on happening. What are the factors that are going to affect this enzyme's activity? That is what we are going to see now. One thing is the temperature and pH. See in this figure, so how pH and temperature is going to affect the enzyme activity. Enzymes generally function in a narrow range of temperature and pH, right? So each enzyme has its own higher activity at a particular temperature and pH also. So we normally call them as optimum temperature or optimum pH. So activity declines both below and above the optimum level. So the lower temperature preserves the enzymes in the what you say that at lower temperature the enzymes will somewhat be in an inactive state, whereas in higher temperature the enzymes will either be higher temperature destroys the enzymatic activities, because what happens, enzymes are proteins, that's what I have told you. So proteins, they normally get denatured by the during the heat. So that is also one thing. So it has to be an optimum temperature is necessary. Without optimum temperature, if you are giving either low temperature, they become inactive, and if high temperature is given, they get denatured by the heat. Next, concentration of the substrate. Like if there are only few enzymes, say like we have only 10 enzymes here, so you should also provide at least one 8 to 10 or 11 substrate is okay. If the enzymes are very less and the substrate are very more, even that doesn't happen. So with the increase in substrate concentration, the velocity of the enzymatic reaction rises at first. The reaction ultimately reaches to a minimum velocity, which is not exceeded by any further rise in concentration of the substrate. Say like all the substrate, you have an enzymes, so only 10 enzymes are there. Starting, if you raise and give a high concentration of substance, that is fine, because all those 10 enzymes are going to utilize anyhow. But once the limit is reached, okay, again if you add some additional substrate, so there will be no enzymes which is ready to get binded with those substrate. That is what they're trying to say. So this is because what, the enzyme molecules are very few than that of the substrate molecules, and after saturation of these molecules, there are no free enzymes molecules to bind with the additional substrate molecule. Next point is the activity of an enzyme is also sensitive to the presence of specific chemicals that bind to the enzymes, and when the binding of this. So the activity of the enzyme is also sensitive to the presence of specific chemicals that bind to the enzymes. That is nothing but, so if the activity of enzymes, there also depends on the presence of certain chemicals that helps in binding or that can also bind to the enzymes. So when the binding of the chemical stuff of enzymes activity, that is if it is been inhibiting the enzymes activity, certain chemicals, we normally call those chemicals as what? Inhibitors. And when inhibitors closely resembles the substrate, that means what happens is, if this is an enzyme and this is substrate, some chemicals, they act as an inhibitors, like they are somewhat resembles just like a substrate, and instead of substrate, they come and they bind to this enzyme. So in that way, what is happening? Now they are going to inhibit certain substrate to bind to the enzymes, right? So these is actually called as competitive inhibitor. The activity of the enzyme that we normally see inhibits the activity of the enzymes, right? Certain molecules. So we normally called as competitive inhibitors. So due to its close structural relation or close structural similarities with the substrate, okay, what happens? The inhibitor completes with they are going to compete with the substrate for binding with the enzymes binding site. Okay, later on what happens, the substrate now it is it's very simple, it cannot bind to the enzyme. As a result, the enzyme's action is declined, so the enzyme's action becomes decreased. Okay, so inhibitors of such examples you can give us dehydrogenase by uh, MemoNeet, which closely resembles, it is actually a chemical which normally closely resembles with the substrate uh, succinate, okay, in structure. So what happens? Such competitive inhibitors are often used in control of the bacterial pathogens also. So classification and nomenclature of enzymes. Enzymes have been classified into six classes, each with 4 to 13 subclasses and named according to the four-digit number. What is that? Say like oxidoreductase, that is dehydrogenase, is nothing but the enzymes which catalyze oxidoreduction between two substrate yes and yes, that is yes reduced or yes oxidized, right? So what happens as a result? You'll be seeing there is a the enzymes which catalyze this oxidoreduction between the two substrate, that is substrate yes and yes. One is substrate reduced, substrate oxidized. So this is what oxido reductase or dehydrogenase is major thing. Next, transferase is another one. So what is the major thing of this? The enzymes catalyzing a transfer of a group. Okay, so that is here the group is G, that is with the substrate now, other than hydrogen. So between a pair of yes and yes. So this is oneness and this is oneness. In middle, what it is there? There is another G more rather than the hydrogen, other than the hydrogen. So the enzymes which catalyzes and it going to remove it and make it different. So can you see here now? Sorry, yes plus yes. And now we are seeing instead of middle, it has gone to the side. Next we have is, so that is transferase. Okay. Next thing we have is hydrolase. So in hydrolysis, what happens? Enzymes catalyzing hydrolysis of ether, peptide, glycosidize or glycosidic, then CC bond, that is carbon-carbon bond, and PN bond, many things. So this can be said. Then we have lysis, is nothing but cutting off. Enzymes that catalyze removal of group from substrate. So there is a substrate. So from substrate, certain group has to be removed. So that mechanism, it is actually, that is hydrolysis of that bond is done by enzyme, that is lysis, cutting down. Okay. Next we have is, say like if this is it, right? We just need to remove this and just something like that. So as ultimately result, what we are going to get. Now isomerase, that includes all enzymes catalyzing interconversion of the optical, geometrical or positional isomers. And the last one we have is ligases, that is enzymes catalyzing the linking together, that is bringing up together, okay, of two components, like enzymes which catalyze joining of C and O compound or C and S compound or C and N and P and O compound, etc. bond. So linking up the bond. The next we have is the cofactors. What are those cofactors? Enzymes are composed of one or several polypeptide chain that we know. Hence, there are a number of cases in which non-protein constituents called as cofactors, they are bounded to the enzymes, okay, to make those enzymes catalytically active in state. So in this instant, what happens? The protein portion of the enzyme is actually called as apoenzymic. So three kinds of cofactors may be identified. So one is prostatic group, coenzymes and metal ions. So what is this prostatic group then, and coenzymes and metal ion? So prostatic group are the organ, or they are actually an organic compounds, and they are distinguished from the other cofactors. Okay, they can be easily separated. So that they are tightly bonded to the apoenzyme. For example, in peroxidase and catalase, so which catalyze the breakdown of hydrogen peroxide to water and oxygen. So what happens? You will see that the prostatic group, and it is a part of an active site of an enzymes, they are getting active here. Then we have coenzymes, which are also an organic compound, but they're associated with the proenzymes. Okay, usually what happens is they're occurring during the course of the catalyze, that is catalysis. During the catalysis, then the coenzymes are occur. So coenzyme serves as what? Cofactors, a number of different enzyme catalytic reaction or catalyzed reaction. So the essential chemical compounds of many coenzymes are vitamins like coenzymes NDA, it could be NADP containing the vitamin sources. Then the number of enzymes require the metal ions for their activity. That means number of enzymes, they also require what? Metal ions for their enzymatic activities, which forms a coordination bond with side chain at the active site, and at the same time from one or more coordination bond with the substrate. Like zinc is a cofactor of what? Proteolytic enzymes, that is carboxypeptidase, right? Then the catalytic activities is lost when the cofactor is removed from the enzymes, which testifies that they play a crucial role in catalytical activities of the enzyme, which is nothing but, so if you remove any, in the during the catalytical activity, if we try to remove any cofactors from the enzymes, so those enzymes, they also remove their catalytical activity role of crucial role. Like they are going to the activity gets decreased. So this states that the coenzymes, that is the cofactors, right? They also play a very crucial role in the catalytical activity of the enzymes. So this was all about what are enzymes and why enzymes are very important. So for any doubt, you can still contact me or reach me out to the comment section. Not only that, you can also follow our Telegram channel. And for more number of questions that you want to, practice, and you want to get the feeling that you're actually practicing the NTA PYQ, oh, sorry, NTA pattern or NTA syllabus pattern oriented, then you can follow the MemoNeet app. Not only that, if you want to, solve or know previous your questions also, you can practice from only NTA PYQ of MemoNeet. So yeah, thank you one and all, and stay tuned. And don't forget to like, subscribe, comment, and also share with your friends. Thank you.